Hello everyone, in this video you are going to learn the following things. The first is you are going to learn how to state Hooke's law. The second is you are going to learn the Hooke's law equation and how to apply it to solve related problems in physics. And then you're also going to learn how to carry out the experiments and also how to plot the graph. So let's just begin without wasting much time. Hooke discovered that the amount a spring stretches is proportional to the amount of force applied to it. This means if you double the force, its extension will double. If you triple the force, the extension will triple, and so on and so forth. So right now, we're going to carry out an experiment to demonstrate Hooke's law. The materials we need are spring. If you have a helical spring, you can use that. We need a rotor stand like this. We need a ruler, and then we need different masses or forces of different sizes. You can see I've chosen from 1 Newton to 6 Newton, and then you will also need a graph page like this or a grid paper where you can plot the graph. Yes. So when you set up your apparatus like this, you need to note the length of your spring, the original length, before you apply any force on it. Yes, you need to note down the length so that you can use this to find the extension E. Yes. So let's see. 1 Newton is applied to it, and then you can see the extension E here, which is 2 centimeters. When we double it, see what happens, and then you can see the graphical representation here as well. This is the graphical representation. We usually plot the force against the extension here. You can see it here. And now it's extended to 4 centimeters. Let's add another force to it and see what happens. You can see the extension. So it keeps increasing in length. So this is what Hooke's law states, that the force applied to a spring is directly proportional to the extension E, or the displacement. You can see it. Let's make it 4, and then it's extended to 8 centimeters. You can see it again, and then this is our graphical representation, which is very straight line. And then when we take it to fifths, we apply another force, which is 5 Newton. Now you can see it starts bending here. So what this means is that this elastic limit can be seen on the graph. So which means this is the elastic limit of this spring, which means that this spring can only accommodate 4 Newton of forces. So this is the strength of this spring. So when we go beyond that, we stop obeying Hooke's law, and then our spring can just lose its elasticity, and that is deformation. So here, this is where it stops obeying Hooke's law. We can see it practically here. So when we take it, we had another 6 Newton force to it. See what happens. You can see it's bending, and then it's going to reach a deformation stage. So you can see. So this is all about Hooke's law experiments, and this is what it states, that the extension E is directly proportional to the force applied to it. Right, so let's see the equation. So we can write Hooke's law as an equation like this. The force applied is equal to the K, and then we have this like a triangular sign, which is delta X. So we usually read this as change in X, change. Okay, so let me just explain the equation. Our force F is the applied force, and it is measured in newtons. And then this X is the extension, which is usually measured in meters, and K is the spring constant. The unit is Newton per meter. The spring constant has to do with the quality of the spring that you are using for your experiments. Yes, the quality of your spring. So that is a spring constant. The extension E, which is change in X, you can also say delta X, but change in X is sometimes written as E, or change in length, or change in L, as you can see it here. You find the extension can be found by using this simple formula, that is change in X is equal to the stretch length minus the original length of the spring. So this is how to find the extension E. We are going to solve 2 examples now to show you how to apply this equation. So here we have a question here. The first question says a wave of 8.7 Newton is attached to a spring that has a spring constant of 190 Newton per meter. How much will the spring stretch? So how much do you think the spring will stretch? So look at the spring here, and then this is the wave that is applied to it. The force is 8.7 Newton. So first thing first, we need to write out all the data we have. So we give in the force is 8.7 Newton. So we write it here. X is not given, so we're looking for it. And then we have the spring constant K, which is 190. 190 Newton per meter. So the equation we need for this problem is the same thing as this. This is our equation, F equal to K times the extension, the X here. And then we just substitute this value into this equation. So we have our F force, which is 8.7 Newton, equal to 190 X. And then we are looking for the value of X here. So we will just divide 8.7 divided by 190, and then we should have 4.6 times 10 raised to the power of -2. So this is the length of the spring when this force is applied to it, or this width. So do not forget the units. So the unit is in meters, so we just put M here. So this is how to apply the equation. Very simple. So let's take in the second example. Here we have the second example, which says that a spring is 0.38 meter long. When it is pulled by a force of 2.0 Newton, it stretches to 0.42 meters. So what is the spring constant? So assume the spring behaves elastically. So we are going to use the same method. It's very simple. So let's write out the parameters we have. So what do we have? So we have change in X, which is going to be the new length minus the original length. So that is 0.42 meters minus the original length, which is 0.38 meters. So we are going to have our change in X as 0.04 meters. So let's keep this here. And then we have the force that is applied. The force is 2.0 Newton. So 2.0 Newton. What again do we have in this problem? The K constant is not given, so this is what we are asked to find. So the equation we are going to apply again is the Hooke's law equation. There's no other equation we're going to use than the Hooke's law equation, which is F equal to K multiplied by change in X, and then let's come here and finish it up. So we have our force as 2.0 Newton equal to K. We are looking for the K constants, multiplied by change in length, which is 0. Okay, we can multiply. So let me just put the multiplication sign here. 0.04 meters. So we are looking for a K here. So which means K is now equal to 2.0 Newton divided by 0.04 meters. So when we divide this by this, so we should have 50 Newton per meter. So this is units of decay constant. So you can see how to apply the Hooke's law equation. So this is all I have for you today in this lesson. In my next video, I'm going to solve my examples, especially those ones that involve two springs. Thank you for taking your time to watch this video. See you again. Bye-bye.